Hi everyone, in this video we are going to discuss about how to find out the trigonometric ratios of compound angles. For example, if we are given two angles, let's say angle A and angle B, and if we are asked to find out what is the sine of A plus B or cosine of A plus B, right? That type of a ratio is called trigonometric ratio of compound angles. Now we are going to find out this trigonometric ratio of compound angles through geometry. So here I have three rays, all of them originating at O, and the first ray is OX, second ray is OY, third ray is OZ. Now the angle between OX and OY is equal to A radian or degree, whatever you may think, right? So that angle is the A angle, and then the angle between OY and OZ, that is the B angle. And now we have to find out what is the sine of A plus B and cosine of A plus B, right? As you can see, the combined angle, if we combine them together, that will be the angle A plus B. I have indicated that with a pink arc. That angle will be the angle A plus B, and we have to find the sine and cosine ratio of that angle, meaning A and B combined together. Now, because we have to find the trigonometric ratio of this angle, we need to form a right triangle with this angle as one of the angles of the right triangle. So let's do this. Let's pick a point on OZ. Let's say I'm taking a point, let's say point P right here. I'm using blue color there. So I have picked a point P right here on the ray OZ, and from P I'm going to drop a perpendicular on OX, and that will form the right triangle. So I have drawn a perpendicular from P onto OX, and let's call it PQ. Now let's also draw another perpendicular onto OY. So from P we are going to draw another perpendicular onto OY. Let's suppose PR is the perpendicular onto OY. So that means this is a right angle right here. I am showing it in red color. So that's a right angle. So PR is a perpendicular onto OY, and PQ is a perpendicular onto OX. Now let's also draw another perpendicular from R onto PQ. And I have used a dotted yellow line to indicate that that is a perpendicular from R onto PQ. And let's name it as RT. So RT is the perpendicular onto PQ, and then from R let's drop another perpendicular onto OX, and let's name it RS. So this point right here is the point S. So let's do a quick recap of this drawing. So from P we dropped a perpendicular PQ onto OX, and then again from P we dropped another perpendicular PR onto OY, and then from R we have dropped a perpendicular RS onto OX, and also we have dropped a perpendicular RT onto PQ. Now if we look at the quadrilateral, which is RSQT or TQSR, if you look at that quadrilateral, you will see that three of its angles are right angles. Now which ones are those? Well, TQS, that is one of them, QSR, that is another one, and then of course QTR, that is also right angle. So if three interior angles are right angles, obviously the fourth one will also be a right angle, and because all four are right angles, this quadrilateral is a rectangle. That means TR and QS, they are parallel to each other. And now if they are parallel to each other, and if we consider OY or OR as a transversal, then you can clearly see that angle A is also hiding right here. The angle TRO will be equal to angle A. Also we know that PRO, angle PRO is equal to 90 degree because PR is a perpendicular onto OY. So angle PRO would be a 90 degree, and PRO is essentially PRT plus TRO, which is equal to angle PRT plus angle A, because TRO is actually the angle A. Now from here can we say that angle PRT is equal to 90 degree minus A. If you consider 90 degree and PRT plus A, then from here we can easily say that angle PRT is equal to 90 degree minus A. You just bring A to the left hand side, and if you think about the little triangle PRT, that is a right triangle, and in that right triangle we can also say that angle PRT plus angle RPT, this is equal to 90 degree. So then from here can we say it like this? In place of angle PRT, I am going to use 90 degree minus A plus angle RPT is equal to 90 degree, and here 90 degree and this 90 degree will cancel each other, and from here we can easily say that angle RPT is actually equal to A. So angle RPT is essentially same as A. So now I am showing that with a green, small little green arc there. Now let's try to calculate the sine of a plus b, right? So what would be the sine of a plus b? Let me write it right here. So sine of a plus b, that will be equal to pq over op. If we consider the right triangle POQ, for that right triangle, sine of a plus b will be the opposite side, which is pq, over the hypotenuse, which is op. Can we write pq as pt plus tq? And tq is equal to rs. So can we write it as pt plus rs? Now why tq is equal to rs? Well, because tqsr, that is a rectangle. We have already proved that, right? So because it is a rectangle, obviously tq will be equal to rs. They are opposite sides. Alright. Now from here, can we write it like this? We can say, well, then this is equal to pt over op plus rs over op. And from there, can we write it like this? We can say, well, then we can write it as pt over something times something over op. Similarly, plus we can say rs over something times that same something over op. And now I'm going to fill in the blanks, and you are going to see some interesting thing here. Now why I am writing it like this? Because using the pt and op ratio, we really cannot convert that into a trigonometric ratio. Similarly, rs over op also would not convert into a trigonometric ratio. So you have to take the help of another intermediate side. That way we can convert them into some trigonometric ratios. Now if we consider pt, and if it is pt over something, so can I say, okay, pt over pr, and then we can say, well, then here I am again writing pr over op. And now you see that pt over pr, that is actually cosine of a, and then pr over op, that is actually sine of b. So now you can clearly see that the trick that we did just now, that way we can convert them into trigonometric ratios. So similarly, for the second part also I am going to do the same trick. So here we are going to say, okay, rs over or, because we have rs, we can use or. So we can say, okay, rs over or, and then or over op. And now let's see what they look like. So the first ratio here, pt over pr, that is obviously cosine of a, times pr over op, that would be sine of b, plus rs over or, that would be sine of a, times or over op, that will be cosine of b. And we have almost found the answer now, and we can write it as sine of a cosine of b. I am going to write the second term first. So sine of a times cosine of b plus cosine of a times sine of b. So we can see that sine of a plus b is equal to sine of a times cosine of b plus cosine of a times sine of b. And of course a and b, they are acute angles. We have to remember that they are acute angles. So let me highlight this. And similarly, we are going to derive the value of cosine of a plus b. So to calculate cosine of a plus b, we are going to use the same diagram, same construction. From the right triangle POQ, cosine of a plus b would be OQ over OP. Now can we write OQ as OS minus QS? Obviously, that will be the difference of OS and QS. That would be OQ. So OQ can be written as OS minus QS. And then QS is actually equal to TR. So I'm going to replace QS with TR. So we can write it as OS minus TR over OP. And this can be written as OS over OP minus TR over OP. And then from here, we are going to do the same kind of trick. So it will be OS over something times that something over OP minus TR over something times something over OP. Now if you look at the triangle ROS, that is also a right triangle, and in the triangle you can see there is a relationship between OS and OR, and that same OR can also be used for the triangle POR. There we will have a relationship between OR and OP. So now I'm going to use OR as the common side here. So I'm going to use OR right here, and similarly I'm going to use OR right there. Now let's look at TR. Well, for TR, if we can use PR as the common side, you can clearly see that PR has a relationship with OP and also PR has a relationship with TR. So let's use PR over there. Now from here we can identify each of these ratios as a trigonometric ratios. So OS over OR would be cosine of A times OR over OP, that would be cosine of B, minus TR over PR, that would be sine of A, times PR over OP, that would be sine of B. So from here we have already obtained the value. So let's make a final note here that cosine of A plus B is equal to cosine of A times cosine of B minus sine of A times sine of b, and that completes our derivation. So let's make a quick note about the sine of a plus b also right here, because I had to erase it because of the lack of space, but let me make a quick note again. So essentially we see that sine of a plus b is equal to sine of a times cosine of b plus cosine of a times sine of b, and cosine of a plus b is equal to cosine of a times cosine of b minus sine of a times sine of b. This brings us to the end of this video. In the next video we are going to discuss about sine of a minus b and cosine of a minus b. Thank you for watching. See you in the next video.